to get before solving. Okay, so saying okay, so we're saying nature of roots. So basically there are three types of roots that we have. Who can name one? There are three under quadratics. Name one. Who remembers one? Yes,
Can
listen.
we raise our hands or?
We are a few. You can just shout.
Okay, I remember.
You remember what?
Hello, sir.
Yes.
Can you?
Yes.
Oh, that's good.
Oh, okay.
We have complex roots.
Okay, complex roots.
Equal roots.
Listen, you are saying something. Oh, it's Namakau. Yes, Namakau. Yes, Namakau. Namakau. Are you guys getting me? Are you able to get me?
No, the network had cut for a bit. Same with the video feed.
Yeah, someone was trying to call on the other phone. So, yeah, the same one I'm using for the audio. Okay, yes. Namakau, you are saying something.
Equal roots. I was saying equal roots.
So, who can polish it up? Listen, can you polish it up?
Real and equal roots.
Good. So we have real and equal roots. What is the third one?
Real and distinct roots.
Good. So we have real and distinct. Now, distinct means different. So real and different. So those are the three types of roots that we can have. But what we use to test for these roots is, if you remember, quadratic formula is x is equal to minus b plus or minus roots over b squared minus 4ac over 2a. You remember this, I suppose. So now for the discriminant, for the test of the roots, we use this one inside here, which we call as the discriminant test. So d, which is a discriminant test, is simply b squared minus 4ac. So this is all what you need for you to know the nature of the roots, where you know your b, you know your a, you know your c for a quadratic, where we have ax squared plus bx plus c is equal to 0. So having known a, b, c, then you can be able to replace your b, replace your a, you replace your c, and then you'll be able to. Hello? Bane ndiri mu class yawa, so sorry ndiratuma kale oloka mtumina wa mulamu. Okay, apologies for that. I hope you're able to get me.
Yes, sir.
Okay, thank you. So I was saying, when you know A, B, C, then you can replace there and get your D. So now it's what you get as your D that determines the nature of the roots. So here, for instance, we are saying here for complex numbers, we are saying d is less than 0. So the moment you get a d that is less than 0, it means here you have a negative number inside the root. That's what gives you a complex root, because that one is not real. You cannot find a real number which has a negative inside the root. You will not get anything real after working out that one. So when you work out that, you're going to get a complex root. Because of the negative inside, you need to form the j and so on and so forth. So then if you get d is equal to 0, that simply means the roots are exactly the same. The roots are exactly the same. So you're going to have two roots, but they're exactly the same. You have x is equal to 1 or x is equal to 1. That's what you're going to get. Then for real and distinct, the d is going to be greater than 0. When you get your d greater than 0, it means you have got real roots but different from each other, distinct. Real and distinct. So real and different from each other. So this is what it means. So for complex, if you are to sketch the graph for complex, it will not touch the x-axis. So if that's the graph, it will not touch the x-axis. If you are to sketch the graph for real and equal, it will touch the x-axis at only one point. It can either be this side, or it can face down, it can face up, it doesn't matter. But it will touch the x-axis at only one point. For real and distinct, it's going to touch the x-axis at 2 points, because it will have two different values of x. So that's what you do there. So let me look for a few questions here that had to do with finding the nature of the roots. Unless if there's any question, we can interact while I'm searching for these questions here. Any questions that we can? Yes, Brandon.
Oh, I wanted to say no, so we can answer the question you have.
Yeah, I don't mean the questions from past papers, but I mean questions that confirms your understanding.
I have a question.
Yes, Namaka, what are you saying?
The formula we use to find the roots is one. They're not different.
The formula we used to find roots, what do you mean?
Is it just one formula, or there are maybe two or three?
So the D that we are using here, we are not necessarily finding roots, we are finding the nature. What type of roots are we going to get? So this D, B squared minus 4AC. This one tells you what type of roots you're going to get before you solve the question. Whether you're going to get real and equal, real and distinct, it doesn't matter. So that one tells you what type of roots you're going to get. That's what it tells you. If you want to find the roots, then you solve either by factorizing, completing the square, or using the quadratic formula. So this one doesn't give you the roots, it only tells you the nature of the roots. Yes, Brandon.
So, for this kind of question, is it usually, it's not a standalone, it's usually followed with another question, maybe a first quadratic that we have to solve. That's when these kinds of questions come in.
It depends. Sometimes it can just come as just a question to give you some to marks so that you don't get a 0. Like this one, it was 2023 AEE. So 2023 AEE. So this is probably question 1D. Okay, question 1D, which says show that the roots of the equation Now, if you had all confirmed that you have the questions, then I may not need to write them on the board. So I don't know whether you have them or whether I have to write the questions on the board. Huh? Okay, so we have that question there, which says show that the roots of the equation mx squared plus m plus n in brackets plus n is equal to 0, so that the roots of that equation are real for all values of m and n. So meaning for all values of m and n, which if m and n are real numbers, then we will always have real numbers, real roots for this quadratic equation. So we need to test or to show that that is true. So we need to come and collect the data that we have. So the data that we have, what is our A according to the information that we have? What is our A? Come again.
M.
Okay, good. So our A is M. What is our B?
M plus
M
N.
plus N.
Okay, so our B is M plus N. What is our C?
N.
Good. So now we come to the discriminant test, because show that the roots of the equation this are real for all values of m and n. So the only way we can show that there's nothing we can solve here. So the only way we can show that the roots are real is by using the discriminant test. So I'm going to say discriminant test d is equal to b squared minus 4ac. So now d is equal to, now for real and equal, we're saying d is equal to 0. For real roots, real and distinct, we say d is greater than 0. Now what about just for real roots? What would be our d? Our d should be what? What should be the sign here? D should be what? Greater than, equal to, or something. What do we get there? To show that the roots are real.
Is it less than, sir?
Less than, it will give us complex roots, Brandon. Here there is b squared minus 4ac. But what should we put there? Okay, what I mean is this our d, the b squared minus 4ac, b squared minus 4ac. There's 0 there. Is it going to be greater than 0? Is it going to be less than 0? Or what is it going to be to show that the roots are real? Not real and equal, not real and distinct, but real. What sign are you going to use there?
Equal roots.
No, the question doesn't say equal roots. It just says to show that the roots are real. So not real and equal, not real and distinct, but real. So what are we going to use there for real roots?
How about greater than or equal to 0?
So why are we using greater than or equal to 0?
Because you said not equal.
Sorry?
No, you said we couldn't put this equal to 0. So how?
Now that becomes guesswork, Namaka. There should be a reason.
Okay.
Maybe
It should
because
be more than
Okay, Brandon want to help, yes?
Maybe because on the number line, when you put greater than or equal to 0, you only get numbers. No, you don't get any negatives. You're guaranteed no negatives, only real numbers.
That's not true, Brandon. Greater than or equal to? No. Greater than, it means greater. Then equal to means equal. So when you combine it means either greater or equal to. So it's just a language. Either greater or equal. I hope you're getting that. So I suppose maybe you mean absolute. When you use the absolute, okay, when you do this, you never get a negative. The modulus, when you use the modulus, it means you are going to get on, you are only interested in the positive value. So now here to cut on time, for real roots, for real and distinct roots, we have this has to be greater than 0. Then that gives us real and distinct. Then for real and equal, it has to be, there should be an equal sign here. So that's why I was asking Namakau, but it sounded like she was just trying because the other one was rejected. So both, it's either it's greater than 0 or it's equal to 0. Then it will give us real roots. Because greater than, it means real and distinct. Equal means real and equal. So we put greater than or equal. That's what will give us real roots. So this is very important, yeah, to notice. So we are working out this. So we get our b, which is m plus n. So I have m plus n squared minus 4. Then our a is m. I'm using brackets to replace. Then our c is n. We're saying this should be greater than or equal to 0. So when you expand this, you're going to get m. What do you get there when you expand that?
M squared plus n squared. Take
Yes.
away 4m.
No, just this. What do you get? That's not true for this expansion here, Brandon.
Oh, I thought I was continuing like with the negative 4.
No, we need to expand this. That's when we can bring the negative 4mn. So when you expand this, you're going to get m squared plus n squared plus 2mn, like this. Just the expansion of this will give you this. This is as good as saying m plus n times m plus n. So when you try to expand that, it will give you this. Unless if you want us to expand it. Okay, silence means perfect. So I'm saying minus 4. When you multiply 4 times m times n, we get 4mn greater than or equal to 0. Okay, so here you're going to have m squared plus n squared. What is 2mn minus 4mn? What do we get?
Negative 2mn.
Negative 2mn greater than or equal to 0. So if you are going to use completing the square method to expand this, having either your m as the variable of consideration, since it's squared, then minus 2mn, then plus n as a constant, or you use n as a variable of consideration, minus 2mn, then as m as a constant, you are going to get m minus n. You're going to get something like this. Yeah, you get something like that. M minus n in brackets, and again m minus n in brackets. That's what you're going to get, which is going to give you m minus n squared. Yeah, but then just from here, if you are to look at this one, it's exactly this, because when you expand this, you're going to get this. So it's either you're going to complete the square or whatever method you're going to use to work this out to get to this, or you can use product sum factor here to get this, Or you can simply conclude that this gives you that. I don't know whether we can, whether what I'm saying to say when you do this, you do that. I don't know whether people are getting anything, or maybe in your heart you are saying, why don't we do what we are supposed to do? So please, let's communicate. To me, it may look very simple and say, okay, this is going to give you that. Or if you want to go further, do product sum factor or complete the square, then you get this, then you conclude that way. Yeah, it looks that simple. So I don't know if I may need to work it out, or maybe we are all okay just with what I have said there. Can I be guided?
I think work it out, sir.
So what formula what are we going to use? What method are you going to use? Because this is a quadratic equation. So there's completing the square, there's the formula, there's factorization. So which one? Let's use the easiest one. Which one is the easiest one?
Product sum factor.
Great. Great. So product sum factor. So let's rearrange this. So which variable are we going to consider? Is it m or n? Which variable are we going to use as our variable of consideration? Like we used m here. Here we had x squared, x, then constant. So which variable are we going to use there as a variable of consideration?
Maybe we can start with m.
Okay. So meaning we need to rearrange this to m squared minus 2 nm, which is the same thing, then plus n squared is greater than or equal to 0. So what's our a here?
Uh,
What's our a?
M.
one.
Listen, you are saying m. When m is our variable of consideration, how can the same m become the a again?
Is it one, sir?
Yeah, so if m is our variable of consideration, then we have x squared here, then our coefficient is 1 here, which is our a. So meaning our a is 1. Then what's our b? Namakau, what's our b?
2, -2.
Negative 2.
Yes.
No, something is missing.
Negative 2n.
Yeah, so we are only m is the variable. It's reducing the power from square to just m. So whatever is everything else that is there, it's a coefficient. So meaning our b is negative 2n. Then what would be our c?
N squared.
Correct. So our c will be n squared. Yeah, so that's what we are going to have there. Okay, that's important. Now we are listing that as if we are using the product sum factor. Okay, so now anyway, this is going to help us also because we know that products, how do we find the product? Is a times c, isn't it?
Yes, sir.
Yes, so a times c gives us the product, which would be n squared. Then what would be the sum? How do we find the sum? How do we find the sum? The sum is just b. The sum is just b. So you pick the b the way it is, that's your sum. 2n, like that. So what would be the factors? What would be the factors? The factors that when we multiply we get n squared, when we add them we get negative 2n. So what would be the factors?
This one's a bit tricky, sir, because of the n.
No, Kai, when we multiply we get n squared. When we add we get negative 2n. So what are those factors? So the factors are simply negative n, comma negative n. When you multiply negative n times negative n, you're going to get n squared. When you add negative n minus n, you are going to get negative 2n. Is that clear?
Yes, sir.
Yeah, so these are the factors that we have. So where there is this, we replace with the factors. So I'm going to get m squared minus n minus minus nm minus nm plus n squared is greater than or equal to 0. That's what we're going to get. So that when you add negative nm minus nm, it's going to give you minus 2nm, like that. So from there now we can say these two, the m is common, so you can take the m outside. Then here are going to remain with 1m minus, here are going to remain with n. Then here the n is common, so we're going to take the n is common, so we're going to take minus n outside, so that here when we divide by minus n, we're going to remain with m. When we divide the minus n into the n squared, we're going to remain with minus n greater than or equal to 0. So you see that there's minus m minus n, m minus n is common, so m minus n. When we take away m minus n here, we remain with m minus, when we take away the m minus n here, we remain with n, so we have that greater than or equal to 0. So m minus n times m minus n, we simply get m minus n squared greater than or equal to 0. So whatever value of m that we are going to have here and whatever value of n we are going to have here, as long as we have the square outside there, it will always be greater than or equal to 0. That's what that means. And this is very true, that we are always going to get this here, because our aim was to satisfy that this is true. So for any value of m and n, so long they are real numbers, when we square them, our discriminant, our d, is always going to be greater than or equal to 0. That's how we show that. So any question? Anyone who is confused? Yes, Brandon.
In the question paper, sir, how many marks was this question worth?
This question had only 5 marks. So this work here, this work from here for completing the square was not very necessary. What you needed to know is m squared plus n squared minus 2mn. This one is going to give you this. So if you're able to conclude here, this gives you that. Then you cut out all this work here. You simply say when you expand this, you get that. Just make a statement that this gives you that. So, and you say hence shown. But if you can't see that, meaning you need to work it out until it gives you that. So sometimes, yeah, you need to be exposed to so many of these tricks and questions so that you are able to know how you can conclude, how you can work out. Any other question? Or are you okay with that, Brandon?
Yes, sir, I am. That's what you explained. So
Okay, great.
just skipped the steps we did there and gone straight to that. They wouldn't deduct marks, so that's giving us 4 marks.
Sometimes the other steps here may not even have marks. Sometimes you have to do a lot of work thinking this is what is supposed to be done. Yeah. So any other question?
For me, it's not a question, but just a statement. I'm happy to go through this because I had no idea.
Great.
I suffered with this question, so I thought I was doing the right thing. So at least I've learned.
Great. Great. No, we appreciate that so much. Let me see if I can have another one, if I can find another one which may be different. If I find something different, then we can as well do it. So next week it will be April, eh?
Yes, sir.
And when exactly are you starting your exams?
14th.
On the 5th, isn't it 15?
Somewhere there.
So after next week, there will only be 2 weeks.
Yes, sir.
Ah, okay.
And
So,
that is always the best one.
which one?
That is always the same.
Yeah, so we need to be very strategic this week because we are, I think we are really running out of time. Because I also need to give myself about a week before you write, you guys. I usually intend to give myself 2 weeks, but now, how things are moving, yeah, maybe I can give you a week before the exam. You cannot be learning until the exam time. So this other one was saying, sure, or maybe we can just move. I think I've gotten the idea. We move to the next part, right?
I think for the sake of time we could, but we can vote on it.
Yeah, check through the past papers. There are some other questions that have to do with the, like this question that I wanted to write here was in this is let me just give you the year. So this is 2023 AEE 2023. So we have question 8C. Take note of that one, question 8C, and then also take note of question 3A. Okay, then also there is question 3B. Question 3B is a quadratic equation which has complex roots. So there you are asked to solve that quadratic equation. So that quadratic equation can also be found under complex numbers. It can come under complex numbers because it gives complex roots. But it's a quadratic equation. Okay, so we are done with that. Let's quickly move to something else. So we move to something else, which is product sum and all these other things. So quadratic topic, it's looks a bit bulky, but there's nothing much that comes here. So I don't know why we're even wasting time on it. But it's important because the 5 marks and the like can also be important. So let's say if we have x plus 1, x minus 2 is equal to 0. Okay, so this is a factor and this is a factor. When you equate this to 0, you get x is equal to -1. Now it becomes a root. So you equate this to 0, x plus 1 is equal to 0 gives you x is equal to -1. This -1 is a root. But the way it is like this is a factor. So also x minus 2 is equal to 0 gives you x is equal to 2. So this 2 is a factor. But the way it is here, I mean that 2 is a root, but the way it is here, it's a factor. Okay. So now when we multiply this, we're going to get x times x, we get x squared. X times -2, we get -2x. 1 times x we get plus x. 1 times -2 we get -2 is equal to 0. So we are forming an equation. So x squared -2 plus 1 we get -x minus 2 is equal to 0. So we see to it that when we have roots like this, we can form them into factors. So when this one crosses the other side, it becomes a factor, which x plus 1. Then this one, when it crosses the other side, it becomes a factor, x minus 2. So x plus 1 times x minus 2, when we multiply the two factors like this, they will give us our original equation. If you are going to solve this equation, these two are going to be your factors without a problem. So whatever formula you're going to use, you're going to find this and that as your factors. And then you can reform them, make them like this, and then they should give you that. Okay, so now when we have, let's say we have ax squared plus bx plus c is equal to 0. If we divide through by a, So we're going to get x squared plus b over a plus c over a is equal to 0. Okay, we're going to have that. Now here, this is where we're supposed to say, suppose alpha and beta are the roots of this equation. Okay, suppose alpha and beta are the roots of this equation, meaning we're going to have x is equal to alpha and x is equal to beta. Just the way we have x is equal to -1 and x is equal to 2. So this is also what we're going to have for this equation if we say alpha and beta are the roots of this equation. So now we can say, okay, when this alpha comes the other side, we get x minus alpha, which becomes a factor. And this one, when it goes the other side, we get x minus beta, which becomes also a factor, just like we have this and that. So now when we multiply the two factors, x minus alpha, x minus beta, when we multiply them here like that, they should be able to give us back the equation, the original equation, which has alpha and beta as roots. Just like what we did here, when we multiplied back this, it gave us this equation, which gives us the roots that we have there. Yeah, please don't get confused. The moment you feel like you are confused, you let me know. So we need to expand here, just like the way we expanded here. So we know when we expand this, we are going to get the original equation. So we need to expand here so that we can get the original equation, okay, which has alpha and beta as the roots. So now when we expand here, we're going to get x times x, we get x squared. X times negative beta, we get negative x beta. Okay, and then alpha times x, you are going to get alpha times x, we are going to get negative alpha x. Then negative alpha times negative beta, we are going to get positive alpha beta is equal to 0. Okay, so this one here, when we bring it the other side, we have x squared. Now here the x is common, so you can, in fact, the negative x is common, so you can take it outside. So I'm going to say minus x. When we take away minus x here, when we divide by minus x, we remain with beta plus, because here when we take away minus x, it will remain with plus also, plus alpha. Then we have plus alpha beta. This is equal to 0. Okay, so this is the original equation, which gives us alpha is equal, x is equal to alpha and x is equal to beta. So this equation and this equation, they're exactly the same. They are exactly the same. Why? Because here I've only used the roots. Alpha, we have removed this, we have converted it into a factor. This one we have also converted into a factor. Then we multiplied the factors to get this equation, of which we know that if this equation gives us these two factors, the two roots, when we convert these roots into factors, this root into factor, and then multiply them, it's going to give us back our original equation without any problem. So now our assumption is also that since we are saying alpha is our root and beta is our root, so the alpha and beta are our roots. So we don't know the exact roots because we are having this A, B, C. So that's why we are using alpha and beta. Should we have these actual roots, it's going to give us exactly back our equation. So now, because we are dealing with alpha and beta, we just know to say this that we have done here has given us back our original equation there. Now, it's from there where we equate the two equations, this one and this one. We equate them together to get, so the x squared goes with the x squared here. There's a plus here, we put plus. There's a b over a, so we have since the x can also be x multiplied by b over a, so that the x can be on one side, because this is multiplying here. So whether it's this side or the other side, is still multiplying, it's the same thing. So we still get the same thing. Okay, then plus, then here we have c over a. C over a is equal to 0. Okay, so that's what we have there. Now from there you see this and that, they're exactly the same. There's x here, there's x here. Now it means these two are also exactly the same. But because this one has a negative, if we are to cancel out, this and that can cancel, this and that can cancel, but here this one will remain with a negative. So this one is simply saying negative b plus alpha is equal to this one, which is b over a. When we divide through by negative, we are going to get alpha plus beta is equal to, this negative here will come the other side to give us negative b over a. So this is what we are going to have as the sum of the roots. So whenever you are summing the roots, you are simply getting negative b over a. So negative b over a gives you the sum of the roots. These roots, you don't know them. So that's why we used alpha and beta, which we don't know. So for any given equation, you may not need to solve it, but you can find the exact sum of the roots by using this formula here. And that's why this formula, we use it, and that's why we need it. Then the other part also, when you equate this, because these are straightforward, so for the product of the roots, alpha beta is simply equal to c over a. C over a. So this is what you have. So if you want to find the product of the roots, there's no need of you to solve any given equation. No, you just need to use c over a. It will give you the exactly product of the roots. Any question before we can solve any given question? Any question?
No.
Okay, I hope everything is clear. So now let's try out something. We just wanted to arrive at these two. That's why we are going around all these circles here. So this is what we wanted to find out. Okay, so now here we have these two roots. These are the roots for this equation. So we have negative 1 and 2. When we add them, let's say sum is going to be 2 plus negative 1, which is as good as saying 2 minus 1, which is going to give us 1. So here the sum of the root is 1. What about the product? We're going to say negative 1 times 2. When we multiply this, we're going to get negative 2. So now let's try to go direct to this formula and see whether we're going to get this and that from here without solving. Let's assume we have not solved this one. We assume all this is not there. Even that is not there. We only have this equation, and we want to find the sum and the product of the roots of this equation. But we don't know the roots. We have not solved them. Okay, so we know our a. What is our a? B is negative 1, C is negative 2. I hope we are all together on that one as to what is our A, what is our B, and what is our C. So our A is 1 here, our B is negative 1 here, our C is negative 2. So this is what we have there. Okay, so now we're saying sum of the roots, alpha plus beta. These roots which we don't know, when we sum them, we're going to get negative. Our b is negative 1, so I'm going to say negative 1. We are replacing as our b the way it is here inside the brackets. But there's another sign here, negative, for that, for the formula, over what is our a is 1. So negative times negative, we get positive. Positive 1 divided by 1, we get just a 1, which is exactly what we have here. Okay, so when we go to the product of the roots, we are saying alpha beta is equal to c over a. So our c is negative 2. Negative 2 over our a is just positive 1. So when we divide negative 2 divided by 1, you simply get negative 2, which is exactly that. So that is how these formulas are used. Any question before we can go and dig through the questions that require us to do that?
No, sir.
Great. I hope it's a no also for Namakau. Yeah, so if you guys had done this, there was literally going to be no need for me to do this, to go through, start searching here and there. Yeah, there will be no need because I'll just go straight. So we can just solve one question, is fine, right?
Yes, that's fine, sir.
Let's just solve one and then we can move to the next part. We're done with that part, then we move on and so on and so forth. So yeah, so this was avionics 2023. So we have question 3b. It says if alpha and beta are the roots, alpha and beta are the roots of the equation of the equation 6x squared minus 13x minus 3 is equal to 0. Form an equation whose roots are alpha minus beta, beta minus alpha. Okay, so we have that question there. If alpha and beta are the roots of this equation, meaning we don't know those roots, okay? So, and then we're saying form an equation. So we're forming a new equation, okay? We have to form a new equation. By the way, there is a general formula for forming an equation which we need to know. So there's a general formula for forming quadratic equations which we may need to know. So the general formula is simply x squared minus sum of the roots, okay, sum of the roots times x plus product of the roots, then is equal to 0. So that's what we have. That's the general formula of any equation you're asked to form. So you need to know what the sum of the roots there is, what the product of the roots there is, then you replace there, then you have your equation done. Okay, so we need to form an equation which has the roots alpha minus beta and beta minus alpha. So you come to the given equation first thing first. So you need to know your A is 6, your B is negative 13, your C is negative 3. Then you need to know what is the sum of the roots. So alpha plus beta, which is equal to negative B over A. So this is equal to negative, our B is negative 13 over our A is 6. So this gives us 13 over 6. That's our sum. Then product alpha beta is equal to C over A, which is going to be our C is negative 3, then our A is 6. So when you work out, this is going to give you negative 1 over 2. So that's what we have there. So whenever you're given such an equation, this is very important. Always start with doing this. Find the sum, product, find A, B, C, then find the sum and the product of the given equation. Then from there now come to the new roots that you are given. So we have the new roots which is alpha minus beta and beta minus alpha. So these are the new roots that you are going to put in that equation which I just rubbed. You need to multiply them to get the product, add them to get the sum. So let's begin with the sum. So sum of the new roots. So sum, we are going to have alpha minus beta plus beta minus alpha. So you see that this is plus, this is minus, this is plus, this is minus. So here you simply get a 0. So the sum of the roots there is going to be a 0. Then we go to the product of the roots. So product of the roots, we need to multiply them. So I have alpha minus beta times beta minus alpha. So we need to multiply them to get the product. So I say alpha times beta, that will give us alpha beta. Alpha times negative alpha to give us negative alpha squared. Negative beta times beta to give us negative beta squared. Negative beta times negative alpha to give us plus alpha beta, like that. Okay, so here there's alpha beta, we can add them. Here there's negative negative, so the negative we can take it outside. So this plus this, we are going to get 2 alpha beta, because there's alpha beta, so you can add them to give us 2 alpha beta. Then here the negative is common, so you can take it outside. Okay, then here I'm going to remain with the alpha squared plus beta squared, like that. Unless if there's a question. Okay. So from here now, we need to this one, because in the formula there we only have alpha plus beta and alpha beta. We don't have alpha squared, we don't have beta squared. So we need to find an expression for alpha squared plus beta squared, which we can replace here. That expression should only have either alpha plus beta or alpha beta. That's all, nothing else. So how do we find that expression? So I'm going to say, if we have, let's say we have alpha plus beta squared. This one is going to be, when you square this, you're going to get alpha squared plus beta squared plus 2 alpha beta. That's what you're going to get when you multiply this one by itself. Alpha plus beta times alpha plus beta. That's what it's going to give you. It's going to give you this. So now here, since we want to find this, the expression for this, so you can take this one the other side. So I'm going to have alpha plus beta squared minus 2 alpha beta is equal to alpha squared plus beta squared. So meaning where there is this, we can replace it with that, and we have no problem. So here it means we have to replace with that. So meaning this is going to be 2 alpha beta minus, now this minus is for this, so I'm going to replace now here. So inside the minus we have alpha plus beta squared minus 2 alpha minus 2 alpha beta, like that. Okay, so here alpha plus beta, we are saying it's 13 over 6. Alpha beta is equal to negative 1 over 2. This one is very important. That information is very important. Okay, so now let's finish up this one here. Let's finish it up, because this is the product which we are going to replace on the product there on in the general equation. So we're going to have 2 alpha beta. Now minus times this, it is going to give us minus alpha plus beta squared. Then minus times minus is going to give us plus 2 alpha beta, like that. So this alpha beta and that alpha beta can add up to give us 4 alpha beta minus alpha plus beta squared. Okay, very interesting. I'm just waiting for Brandon to ask me how many marks. Yeah. Yeah, I think this one should have about 7 or so. Yeah. So now here we replace our alpha beta there. That was the reason of finding the sum and the product. So here I'm going to replace the product. So I'm going to say 4 times negative half, negative 1 over 2, because that's the product of the roots. Then minus, here the sum is simply 13 over 6, then squared. So these 2 here 1, these 2 there 2. So 2 times negative 1, we get negative 2 minus, what is 13 squared? What is 13 squared?
169.
169. So we're going to have 169 over 36. So this is over 1. Common denominator, 36. 1 into 36 is 36. 36 times 2 is negative 72. Minus 36 into 36, 1. 1 times 169 will get 169. Then what is negative 72 minus 169?
Negative 241.
Yeah, so you get negative 241 over 36. So this is our product. Negative 241 over 36. That's our product. So now we come to the equation, the general equation. We come to the general equation. Now we're going to say x squared minus sum of roots x plus product of roots is equal to 0. This is the equation now which we are supposed to form. So we come, we say, so the equation will be x squared minus, remember the sum was 0, 0x plus, now because there's a minus here, so this will be minus 241 over 36 is equal to 0, which is going to give us x squared minus 241 over 36 is equal to 0. Now we can decide at that point to multiply through by 36 everywhere, so that when we multiply by 36 here, 36 times x squared, it's going to give us 36 x squared minus 36 times this, 36 and 36 will cancel, so we're going to have 241, then is equal to 36 times 0, you get 0. So this becomes our new equation. Any question?
No, sir.